size and all this. After this, we're going to learn on. Okay. Now, okay, of course, we want to control our plotting limits. Okay, so we put as before this we use GCA, H is equal to GCA. Okay, now we're going to use B is equal to axis semicolon. Okay, so what is it? Okay, it's a function return 4-element row vector. Okay, which is you can have when you put V is equal to axis here, you can specify X your minimum x-axis, your maximum x-axis, y minimum and y maximum. Okay, and if let's say, okay, if you want your axis x and y to have an equal increment, so which means that for x-axis will be 0, 1, 2, 3, 4, y-axis also will be 0, 1, 2, 3, 4. Or maybe you want to do x-axis 2, 4, 6, 8, and y-axis also 2, 4, 6, 8. If you use axis equal. Axis square means, okay, is make the current axis box square. So which means that your limit and your minimum and your maximum for x and y both are equal. So which means that if let's say maximum for x is 5, minimum for x is -5, y also the same because we want to make it square. Okay, okay, and x is normal. Okay, so which means that we put MATLAB to decide for us, use the default value. Axis off means, okay, we turn off all axis labeling, tick marks and background. We don't want to see any of that. Okay, sometimes we only want to, we don't want to see any axis value and all that, or we put as an axis on. So we're going to turn on back again. Okay, turn on back all axis labeling, tick marks and background. Okay, so this is how you do your graph. Okay, now, okay. Okay, so please comment all the previous value. Okay, and type the new coding in my screen. Okay, I have a new variable. I put name as xm, y from -7 to 3. This one I put by default. Ym is equal to xm to the power of 3 plus 6 times xm to the power of 2. Okay, it's the same. Okay, then I put as hold on. Okay, this is how you're going to do for marker color and marker size. Okay, marker color and marker size. Okay, so first of all, okay, I draw the red graph. Okay, like we do it previously. Then here, this one is marker for X and marker for Y. Okay, we overlap the marker into the line. I repeat again. First, we create the graph of red color. Okay, then after that, we overlap the marker, okay, into the graph. Okay, why we cannot do simultaneously? Because MATLAB, we store memory from one process to one process. Okay, so here, because we want to use the marker, right? So we put here hold on. Okay, we put as hold on, which means that we hold the graph, we hold the red line graph, then we overlap with the marker. You understand? We hold the red line graph, then we overlap with the marker. So the marker here, I put as size 10. You can also specify like 5. Okay, the marker green color is G and the marker H color. What is H color? The outline of the box. The outline of the marker is red color. Okay, let's say I want to change. Let's say I want to change green and marker red color here. I want to change as black. Black is K. Okay, marker size maybe I want to make it, I remain the same. Okay, so you see here, my marker red color, the outer value is equal to black. Okay, and if you notice here, after I finish, let's say I want to do more marker, then I don't put hold on. But now I finish my graph, then I put it as hold on. Okay, I put as hold on. Okay, if let's say I want to put more value, okay, I put, let's say this one is XM1. Maybe I want to do SM2, right? So if I want to do SM2 and YM2, okay, I will continue it. I put this more, hold on, then put more value. Okay, I put more value, thing like that. Okay, so okay, so if you notice, this is square S. Okay, you can also change the marker. Okay, you can also change to marker to other the shape. Maybe I want to put, okay, let's Google it. I also can't remember. Uh, Marker. Yeah, here. Okay, for marker. Okay, if you put this like here, uh, oh, sorry. Yes, small letter O, you will get like this. Okay, or you can put it as circle. Okay, I use square S. Okay, you can also change to diamond or this one. Okay, let's say I want to use this one, hexagram. So I can change it. Okay, let's say I want to choose hexagram, right? And then I just change it. Okay, you see here, my marker has changed into this symbol. Okay, hexagram. Okay, previously I used square. Okay, you just find it in a mark center. You type it as a graph node, graph node, graph node. What is it? Graph node and age. Okay, this one also RGB color. Okay, let's say now I don't want hexagram. I want circle, so I write it as circle. circle C, big C, big C. Circle. Something like this. Okay, you can specify it. Okay, now, do you get it? Marker, you get the output? Everyone got it? Yeah? Okay, this is only one marker. Let's say if you want to have like multiple marker, then you use hold on, then add more marker. Use hold on, add more marker until you finish labeling all your marker, then you put hold on. Okay? Can I continue? Girls at the back, may I continue? Yeah? Okay. So, okay, now we can use this save as. Like I said to you, we can just use the from current figure, then you just save. Okay, using from figure window, you can just save it. Okay, but you can also use coding to save your figure. Okay, so save as is by default you use fig is fig file in MATLAB. Okay, .fig. File name, save the figure of Simulink block diagram specified by fig to file name. Okay, specify the file name as a character or string that include a file extension. Okay, you can also change into JPEG. Okay, and you can also change it to PNG and what else. Okay, so let's look at our, let's say this is our graph, right? Okay, I run it. Okay, this is my graph. Okay, I can save it here. Save, okay, here. Or if I want to use the coding, okay, so I put here as, okay, save as GCF. So the name is GCF. Okay, and the name, sorry, save as GCF. Okay, first the name of my file is first polynomial figure, and it is in fig format. Okay, so it will save it. Okay, it was save as this. This is how you do it. Okay, but okay, you can use your own name. But usually, if you want it fast, you just straight away save it from your figure window. Okay, you can straight away save it from the figure window. Are you clear? Are you clear? Okay. Okay. Okay, so what if we have multiple data sets in one plot? Okay, what if I have a multiple data sets in one plot? Okay, and if you have normally a new plot is created each time that a plot command is issued. The behavior can be modified using the whole command. Okay, using the whole command. Hold on forces additional plot to be laid on top. Okay, so which means that we hold, then we overlap it of the previously existing plot while hold off switch back to default behavior. Okay, the figure. Usually we put figure, right? Text from the figure and when execute n becomes the current figure and the polynomial figure is created if it did not already exist. Okay, so now we are going to look at the polynomial function. Okay, so if we have plotted multiple dependent vectors on the same plot and want to distinguish them from each other, we use a legend. Okay, we use a legend either during plotting or so after plotting. So let's say we have not just one marker, we have two types of marker. So we use legend, okay, to give symbol to that. Okay, it is also possible to set color of different vector and to change the location of the legend of the figure. Okay, now open your Matlab. Okay, we're going to use the same thing. Okay, we're going to use the same thing, X and Y, but now I have x2, y2, x3, y3. Can you copy it now? You copy it now? Okay. Okay. I scroll down. Okay, now. Okay, I plot, then I put whole of. Okay, then again, I will use GCA function. Okay, we start y-axis origin, x-axis origin. Okay, but here my x limit and y limit also I put. Okay, you see here my y limit. Okay, minimum I put this as y max, and the other one is y2. Why? Because we have three different y, right? So we want to make it nice. Okay, then we put box off, and this is the legend. Okay, can you do it? Okay, for this one, I copy and put in your Teams. You can, okay, I put in Teams. Okay, I put in Teams, copy it, then put in your MATLAB. Okay. Okay. Here, the, okay. Now, okay, you see from the beginning, I explain to you one by one. Okay, my act is we start with the equal value. It's not equal. Equal interval from -5 until 201. Okay, and increase every 5. Okay, and this is my y. And after that, we want to plot the first graph, which is R in red line. Okay, x, y, r, red line. So with these two. Then after that, I put x2. Okay, the same value, -5 until 5. Okay, sorry, -5 until 5. Yeah, we that we have 201 values, and y2 it is an exponential graph x2 to the power of 3. My x3 also the same. Okay, but this one to the power of 2. Then I put as hold on. Okay, hold on. So which means that, okay, we have plot x and y. Then we hold on to plot x2 and x3. Okay, so after we plot the first graph, we put hold. I repeat again, this is important. After you plot your first graph, you put hold on. Then you plot x2, y2 with green color. Okay, then I plot x2, x3, y3 with magenta, is pink color. Both line with also 2. Okay, then you put hold on. Okay, of course, without the GCA, your graph will be very messy. Okay, your graph will be very messy. So we start at origin, y also start at origin. We specify the x limit, y limit. Okay, then here, I don't want border for my graph, so I put as box off. Okay, I put as box off. Okay, you see here, we have 3 colors. Of course, we need it to be, we need to do a legend for it. Red color is x cubed plus 6x squared minus x minus 10. So I wrote here. Okay, this one I didn't do italic, but also I can also do italics with /it. Okay, you can also do italic here. Okay, so you see my first equation here is italic. Okay, my second equation and third equation is not italic, normal. Okay, then after that, we put this location. Okay, my location I put here, north is outside. So which means that north is outside means north is up, east is on the right, outside. So which means this out of the graph. Okay, I don't want it to be overlap here on the graph. I want to be out of the graph. So I put it as north is outside. Okay, let's say I want it to be here. So I change it to become south is outside. Okay, south is outside. So let's say here I change to south. Okay, I want to change it become south. So Okay, south is outside. So now the location, okay, has changed, which is here on the bottom. Okay, so now let's say I want to not to be on the right, I want to be on the left. Okay, so just change it. South is west outside. South is west outside. It will be on the left here. Okay, it will be on the left. Okay, so if you don't put outside or inside, okay, it will be overlap in your graph. Okay. Change now first. Okay, see here is on west on the left, okay, but on the left, but inside the graph. Okay, it's not outside, so it is in the graph. Okay, so this is how you do a graph, okay, with many line, multiple data, and with a legend. Okay, and with a legend. Okay, this one doesn't have any title, doesn't have any axis level. You can do by your own. Okay, you can do by your own the title and the axis level and all. Okay, so your coding will be longer. Okay, everyone got it? Got it? Yeah? Okay, everyone got it? Okay, so this one, you see the line is only, you see, is a straight, not straight, it's like solid line, right? You can also change it into other line, dotted line, dash line, or other line. Okay, so this one you can also, okay, here, line style, dash, or you want to do like this, okay, or you want to do like this, or like this, dash dotted. You can also specify that. Okay, you can also specify that. Okay, so you can explore more, okay, in MATLAB Hub. Okay, sometimes we don't want one figure window only have one graph. We want to have a multiple graph. Okay, at one figure window, we want multiple graph. Okay, so we use the new function we call it set subplot. Okay, it is possible to place more than one set of axes on a single figure, creating multiple subplots. Okay, subplots created with subplot command. So we put a subplot M and P. Okay, this command divides the current figure into M by N equal region, arranged in M rows and N column, and create a set of axes of position P at position P to receive all current plotting command. Okay, so what is it? Okay, so let's say I use subplot 2 to 1. This is what I get. If I put subplot 2 to 2, okay, this is what I get. So subplot 2 to 3 and all this. Okay, so this one is how to create, okay, each. So this is subplot 2 to 1, subplot 2 to 2, subplot 2 to 3, subplot 2 to 4. Okay, so MATLAB will know that it has 2 rows and 2 columns. Okay, so every graph represents, so the first graph is subplot 2 to 1. The last graph is subplot 2 to 4. Okay, let's say you don't want 2 by 2. You want like this. Okay, 2 by 2, but okay, this one 2 by 2, but this one first graph is dominating first and this is dominating the first row and second row. Okay, so this one, subplot 2, 2. Okay, 2 column, 2 rows, because we want 1, 2. Okay, vertical is also 1 and 2. The column also 2, row also 2. Okay, this one is subplot 2, 2, 1, 3. Okay, subplot 2, 2, 1. This one is subplot 2, 2, 2. Okay, and this one is subplot 2, 2, 4. Okay, because it will be 1, 2, 3, 4. So subplot 1, 3 means it merge. Okay, it merge column 1 and column 3. So it merge column 1, it merge row 1 and row 3. Okay, it merge row 1 and row 3 because MATLAB will calculate it as 1, 2, 3. So you want to merge this, you mean 1 and 3. Okay, this is if you want to make it like vertical. But what if you want to make it horizontal like this? Okay, so this one also 2 row, 2 column. Okay, 2 row, 2 column. So this one is 1, 2, 3, 4. So this one is subplot 1 and 2. We merge it 1 to 2. Okay, so you will ask me, Miss, why this one we use square bracket, but this one we use this? Okay, because we want to differentiate to merge column and merge row. For bracket, okay, we merge row. For column like this, we merge column. Okay, for semicolon like this, we merge column. Okay, for bracket like this, we merge row. Okay, and subplot 2 to 3 is here, subplot 2 to 4 is this. You get it? Okay, so now let's demonstrate how to do subplot. Okay, I will copy it, then put in Teams. Okay, I copy it and put in Teams. Okay, first of all, okay, we have Boolean space from -5 to 5, which has 201 units, and Y also the same. Okay, here we put subplot 1 row, 3 column. Okay, this we're going to plot the first graph. Subplot 1 row, and we have 3 column. Okay, so plot XY, okay, red line width is 2, and we start, okay, same, start at origin. When we specify maximum, minimum, then we put the title. Okay, next is our second graph. Okay, x to the power of 2. Okay, this one is a subplot. Okay, subplot 1, 3, 2. So which means that first row, at first row, but second column. We plot it, then we put the same thing. Okay, and subplot 1, 3, 3. So which means at the third column. Okay, and this. Okay, so let's do it. Okay, so you will get 3 graphs. Okay, you will get 3 graphs like this. Okay, this one I put box on for all because we have 3 graph. Okay, I put border everything in everything. Do you get it? Okay, for those who use in lecture, I will share the code, but not all. Okay, some of it. Okay, so this one we have learned how to create a continuous graph. So which means that our graph doesn't have any different function or same function. What if our x is between 0 to 3, this function, 3 to 5, different function, but we want to plot in the same graph. Okay, so we're going to learn it in 2.2, piecewise function. Okay, now it's 10:40. We begin at 10:20. Have a break. Okay, have a break. Then we begin next at 10:20. All right.